All right, we're going to have another short video, and this one's going to be about error. And in the world of error, there's really two types of error. There is random error, and there is systematic error. And random error is where you were to take a measurement and you would get a slightly different result each time. And those results would move up and down, not in one particular direction. That might be called a trend or something. But if you get a random error, then you get a slightly different result each time. Okay? A systematic error is one in which you get the same error each time. And this is really, really subtle. Um, a systematic error means there's something wrong with your measurement. You're getting the wrong answer. And in fact, that assumes you know the right answer. And many times in science, we're just making a measurement. We don't know if that's right or not. But let's just say that you knew that something was 1 meter long exactly, and you went and measured it with a meter stick, and you kept getting 98 centimeters over and over again. You would have some sort of systematic error associated with it. This is easier to, if you find it, it's easier to figure out what's causing it. These are things you just have to put up with. But these lead to two different ideas in the world of error, and that is that numbers can have uh, accuracy and precision. Now, these are related, but it's not exactly the same. Accuracy versus precision. I'm going to send you after this video to watch a video on YouTube. And accuracy refers to how close to the right answer the average value is. Oh, that's not really a good sentence because I ended with the preposition. Oh, that's horrible. I'll have to fix that up sometime. And then precision is how repeatable is your experiment or your measurement. And to illustrate this, I like to talk about going to the gun range. Okay, so you get yourself a paper target and you get yourself your little 22 pistol and you shoot the target a whole bunch of times. Now the target itself, and I'm going to draw 4 targets down here. This is going to be a bit painful for you guys to watch, but here it is, and we're getting through it. And each of these has a set of circles and a bullseye, a set of circles and a bullseye, and a set of circles and a bullseye, and a set of circles. Oh God, the edges of the paper are unstable, and a bullseye. Okay, so I'm going to go ahead and I'm going to shoot this target with a firearm that is accurate but not precise. Okay, accurate but not precise. This would be an indication of someone who is aiming the gun but doesn't have very good technique. So you might hit the paper here, then there, then there, then there. Let's shoot 6 rounds. Okay, there we go, 6 rounds. Now, none of those rounds has hit the bullseye, but the average of all these things is right about here. So that's a pretty accurate, but not precise thing because they're not repeatable. Now, somebody who was precise but not accurate might have the bullets all hitting in a very small area. The average is, of course, inside this little circle right here. And this would be precise but not accurate. We can imagine somebody with a rifle and a scope, but the scope is not necessarily lined up with the barrel of the gun, or maybe there's a little wind or something. And I'm sure you've seen plenty of movies where people have to shoot the rifle a number of times to figure out how to adjust the scope. That rifle may be very precise and puts the bullet in the same place every time, but it's nowhere near the correct answer. What would accurate and precise look like? Why, we would have a very small cluster of hits very close to the bullseye. What would not accurate and not precise look like? Well, then we would have a scattering of bullet holes, and they would not really center. There might be a whole bunch of them up there, and then two of them down here. So the center of this group is going to be much closer up here. Like maybe that's the average position of all these bullet holes, and it's not near the bullseye. So this is not accurate and not precise. Okay, so that's the difference between accuracy and precision. Accuracy is how close to the right answer you are. Precision is how repeatable. Precision has a lot to do with your tools, your measuring instruments. The more money you spend, the better system you use to measure things, the better precision you're going to get. Accuracy, why, that has a lot to do with your technique, I think, when it comes to using tools. If you use a ruler and you don't line the end of the ruler up exactly the same place every time. You know, when you go to the shoe store and you got to stand in that little shoe measuring device and they put your heel against the back of the device and then your toe goes out and they measure where your toe is by sliding something in. They're trying to get an accurate measurement of the length of your foot, particularly when it's under stress, when you're standing on it. Could you do better? Could you stand on an electronic device that senses where your foot is? Yeah, it's possible, unless you have protrusions that go above the bottom of your foot. So I just wanted to get this out here. This is the difference between accuracy and precision, and random errors versus systematic errors. That's some terminology we might use. And we'll pick up on this next lecture.